Okay, so let's talk about adding and subtracting fractions for a minute. What has to be true about fractions for us to add and subtract them? Denominators have to be the same. And that's just a rule for fractions. So it just has to be that way, that if you want to add or subtract something, the denominators have to be the same. So denominators are the same here, yeah? So how would we add up these two fractions? Okay, add the top. What 1 and 3 is?
4.
What about the bottom?
5.
Why not 10? Good, you don't add the denominators together when you add fractions. They just have a common denominator. So what about this one? 6 sevenths minus 4 sevenths. How much? 2 sevenths. We just do the numerators, we subtract the numerators, the denominators stay the same. How about 1/2 plus 2/3? Well, those do not have the same denominator, so what do we do about that?
Get a common denominator?
Okay, let's do that. What is a common denominator for 1/2 and 2/3? Okay, so let's see what this would be. What is 1/2 is equivalent to how many 6?
3 6.
And 2/3 is equivalent to how many 6? Okay, 3 6 plus 4 6 is? 7 6. So we can write that as an improper fraction or 1 and 1/6. Either way is acceptable. Okay, keep that in mind because that is what we are going to do here. And it's very important that we actually pay attention to a lot of this because it looks a little bit harder when we're dealing with algebraic expressions. All right. What do you notice about this that we're about to add two fractions? What do you notice right away that is like the what? Denominators are the same. That's useful. So we know the denominator is going to end up as x plus 3. So what do I do with the tops then? We're just going to add them. 3x minus 4. So we've got 3x minus 4. Some of you are in other conversations. I hope you're not falling behind them. Okay. 3x minus 4 plus 2x plus 5. How do I do that? Okay, 3x plus 2x is? And negative 4 plus 5? So we get 5x plus 1. Now, this asks us for two things. To simplify, and then tell where the expression is undefined. Well, where is it undefined?
The variable x.
What do you mean? How do I find where this is undefined? Good, we're going to look at the denominators and say, okay, well, here is what my answer is, but where is it undefined? Well, we need to figure out x plus 3 equals 0. So x is equal to negative 3. X is not allowed to be negative 3. That's where it's undefined.
So the answer would be 5x plus 1 over x plus 3, and then also x is 1.
Correct, because it answers both questions. The first part answers the first part, and that x cannot equal negative 3 answers the second part of where is it undefined. I feel like it's the second one where there is an easy mistake to be made. Actually, I could see two easy mistakes that could be made. Talk to me. Well, what do we know first? There's something I should check first. We're subtracting, so I need to make sure there is a what? I heard like 3 things there. Common denominator. Before we do anything, do they have a common denominator? Yes, they do. Okay. Now, what did you say? Somebody said distribute. Talk to me about distributing.
Since you're subtracting, then you have to distribute the negatives to both 4x and 4.
Yes, you are subtracting that whole thing, and this is what gets people. You are subtracting 4x plus 4, which means you have to subtract 4x, and you have to subtract 4. So we're distributing that negative over both things there. And that's no different. That's no different than you do with numbers. Like when you do your order of operations, that's no different. Same exact thing. So we've got 2x minus 4x, which is negative 2x. And negative 1 minus 4? Negative 5. So we get negative 2x minus 5. There's my simplified version there. Why can't I break down the bottom into the sum of two squares? Because that's not a thing. The sum of two squares is not a thing. The difference of two squares is the sum of two squares is not. All right, so how do I figure out where this is undefined?
Put x squared plus 2 to 0.
Now what?
Minus 2.
Now what? How do we turn that x squared into an x?
X plus 2 and x minus 1.
Somebody was about to say it, but they got kind of drunk. Square root of both sides. That's how you turn an x squared into an x. But how do I take the square root of negative 2? We can't. Just so you understand, at this point, we can't. You and I cannot do that yet. We will be able to do that soon. So we're going to leave this as our answer right there. We cannot take that any further. You will be able to take it further. X cannot equal plus or minus the square root of negative 2. Now, you may be like, that makes no sense, that answer. I understand. We will get there to the point eventually where we can explain that away. Yep?
Why is it plus or minus?
Because whenever you take the square root of both sides, you have to do plus or minus. Like if you do x squared equals 16, would you agree that there are two numbers that could be squared to make 16? Like 4 times 4 and negative 4 times negative 4? Same reason why. All right. So we've got our two parts of our answer there. Right here, answers the simplified part, and this is our area that it's undefined. All right. Talk to me about C. I'm going to try to shut up during this, and you guys try to walk me through it.
Well, they have the same denominator,
Good.
so you just add
Okay, talk to me.
9x plus 4.
Okay, 6 and 3 is 9. 5 and negative 4 is a positive, 5 and negative 1 is a positive 4. What else? That's the simplified version. That was nice and easy.
And then you do x squared minus negative 2.
Here's where we're figuring out where it's undefined.
And then we add 2, and then we add 3. So then x squared equals, and then do the square root.
Now, I don't know the square root of 3, and that's okay. Don't feel like you've got to break that down further. The square root of 3 is a number. We can leave it like that. X cannot equal plus or minus the square root of 3. Don't try to break that down. It's going to be more difficult than you think. A lot of people will try to say that's 1.5. It's not 1.5. 1.5 times 1.5 is not 3. 1.5 plus 1.5 is, but not 1.5 times 1.5. Just leave it just like that. So my two answers are, here's the simplified version. Here is where it is undefined. Let's keep going.
Same denominator.
Same denominator.
You distribute the negative.
Good. So I'm going to write it like this. 3x squared minus 5. And it's subtracting everything that's over here. Minus 3x minus 2. Just so you can see what I'm about to do. I'm about to distribute that negative into everything that's in that parentheses there. So we get 3x squared minus 5 minus 2x squared. This negative is being distributed here, and a negative times a negative, for those of you who are having side conversations, will be a positive. A negative times a negative again will be another positive, all over 3x minus 1. Talk to me about that numerator.
You combine that 3. One is x squared. Less the x.
Over 3x minus 1. Now, sorry, go ahead.
Would you get the same answer if for the second numerator if you did the factoring?
If you factored this right here,
No, back first one, like from the very first.
you have to see if it factors. Not everything factors. You could check to see if it factors. If it does factor, then yes, it will. Yes, ma'am.
Could you just subtract the individual terms?
That's what we did. So when you subtract 2x, it becomes negative 2x. When you subtract a negative 3x, that becomes a positive 3x. We're doing the same thing. When you distribute a negative, it's the same thing as subtracting each individual term. Same exact thing. All right, but where's my restrictions? Where is this undefined?
But you would have to factor that.
Well, we can try. We can see if something cancels out. Like let's check it out. Do you know two numbers that multiply to give me negative 3 that will add to give me positive 3?
Oh, no.
So, no, I mean, it was a good thought. It really was. It was like, hey, but I mean, I guess I just looked at it and I probably should have said something that I just was like, oh, I couldn't think of two numbers that would multiply to give me negative 3 that would add to give me positive 3. So I was like, that's not going to happen. So let's go back here. What am I doing here?
Add 1. Divide 3.
So x cannot equal 1/3. So we've got this answer, and x cannot equal 1/3. That's our restriction there. That is where it's undefined. Okay, so we're going to talk about the least common multiple. To find the least common multiple of a polynomial, so when we talk about the least common multiple of 2 and 3, we're not looking for the least common factor. We're looking for the least common multiple, meaning what is a number that these will both go into? It's like finding a common denominator. It's like finding a common denominator for these two numbers. You look for the least common multiple, the smallest number that they will both go into. And that's what we're going to be doing with polynomials as well. We are going to do the same things we always do. We're going to factor each polynomial completely, and then we're going to write out all the factors. So those factors are going to have exponents. Then we're going to list all those different factors, and if they have a common factor, we're going to use the highest power. For example, let's say we've got x squared and x. Those two are both x's. We're going to use whichever one has the highest power. Which one of those two has the highest power? X squared. This will make sense once we start doing them here. So the first thing we're going to do is we're going to factor each of these completely. So there's really no factoring to be done here. There's no GCFs to pull out here. We're going to find the least common multiple for these two things. So if you think about it, this is actually 2 times x cubed times y to the 4th power, right? And then this one over here is 3 times x to the 5th power times y to the 3rd power. I'm not doing anything other than just talking about exactly how that's written. So I want to look at those two things and find out what is the highest multiple letter, number. Let's talk about the letters first of all. Let's look at the x's. What is the highest number of x's that I have anywhere? X to the 5th. That's the highest, right? We got x to the 3rd and x to the 5th. X to the 5th is the highest possible one. X to the 3rd will go into x to the 5th, right? Because we know that x to the 3rd times something will give me x to the 5th, right? What is that something that should go there? X squared. So it'll go into x to the 5th, no problem. It'll go in there, definitely. So the least common multiple for those two things is whatever the greatest power of that is. And I can see that's x to the 5th power. What about the y's? Y to the 4th. We're just picking out the highest powers. Now, 2 and 3 do not have the same base, but let's think about it. We already know how to find the least common multiple of 2 and 3. What is the smallest number that they will both go into? 6. And you know how you get that? 2 times 3. 6. So the least common multiple for these two things is 6. X to the 5th power, y to the 4th power. All we're doing is picking the greatest the highest power for each of these factors. We look at the x's, we pull out the highest power. We look at the y's, we pull out the highest power. We look at the numbers, we're going to multiply them together and get another one. So no matter what, we're looking at those highest powers there. So when we look at these here, it's a little bit remember we said our first step was to factor these completely. Well, these, it looks like probably could be factored. Let's try factoring the first thing. How do we factor that?
X.
X plus 4, X minus 1.
And what about the second thing over there?
X minus
Okay, so what we've got here is we're going to look at how many unique things we have, right? We only have one x plus 4, right? There's only one x plus 4 up there, yeah? So I'm going to write x plus 4 as one of the factors. That's definitely one of our factors because that's one right there. There is an x minus 1, but there's not just one of them, there are two of them though right there, so I don't need to write it twice, x minus 1. I'm just making sure I have each of the factors here. What else am I missing over there? X minus 2. I'm taking each of the factors. So notice that this is x minus 1 to the first power and x minus 1 to the first power. So I'm taking the highest one, which is x minus 1 to the first power. No different than what we did last time. It's just they were both x to the first power, so I took one of the x to the first powers. Now, what we are going to do is we are going to multiply this out. Now, I don't care which two you pick, but pick two of these and let's multiply them together. How about we just pick these just because? No reason I didn't pick it other than, like, what I'm going to do is I'm going to say we're going to have x plus 4 times whatever this works out to be. So let's actually figure out what is x minus 1 times x minus 2. X minus 1 times x minus 2. How do I do that? FOIL. The first term times the first term is x times x, which is x squared. The outer terms are x times negative 2, which is negative 2x. The inner terms is negative 1 times x, which is negative 1x. And the last terms are negative 1 times negative 2, which is a positive 2. What does that simplify to?
X minus 3x plus 2.
Okay, so we're in a good spot. What?
I didn't understand.
All we did was just FOIL it out. So all we did is FOIL. But I still have more work to do. I still need to do that x plus 4 times that x squared minus 3x plus 2. I don't want to factor that because it'll just take me back up to the line above it. Right there, I am just trying to get this to all the different things here. So what we're going to do is we are going to distribute this x to each of the things over here. X times x squared is?
X cubed
X times negative 3x.
minus 2x. I mean, sorry, minus 3x squared.
X times positive 2.
2x.
Now I'm going to distribute the second thing to each of those. 4 times x squared.
4x squared.
4 times negative 3x.
Minus 12x.
4 times 2.
8.
Now let's just combine anything we can, and then when we're done, we are going to be done. Okay, these can be combined. So the x to the third power combines with nothing. But those two green underlined things are going to combine to become just x squared.
2x minus 12x is negative 10x.
Okay, these two here are going to become negative 10x plus 8. So we're looking for the least common multiple of these. This is the smallest thing that all of those will go into. So what we did is we factored completely. We pulled out the highest powers of each, and then we did any multiplying that we have to do. We multiplied it all out, and this is what we got. X cubed plus x squared minus 10x plus 8. Why am I not looking for where this is undefined on this one? It's not a fraction, so that shouldn't even be an issue. Like, that's not even a thing I need to worry about anymore. Riley?
Okay, I'm confused on the second one. Like, you did x plus 4, x minus 1. X
Here?
No, not under.
Here?
Yeah.
We took the greatest power of each. There was an x plus 4, an x plus 4. And x minus 1, well, there were two of those, so we just took whichever is the greatest power. Well, they're the same power, so I just took it to the first power. I just took one of them.
Okay.
Then I've got an x minus 2. I pulled that down as well. Yes, ma'am. Bella.
Why could you have used x before?
Yeah, you could have multiplied any two together. It'll end up the same. Imagine this. If I did 3 times 4 times 10, you can multiply that in any order you want. We'll all still end up as long as you do your math right, you'll end up in the same thing. It doesn't matter the order of which you multiply things. It's just, I just chose those two just because. Yes, ma'am.
Why can't you, sorry. Why can't you pull out an x and then
And pull out an x from where?
x to the third plus x squared minus 2. He does. The 8 doesn't.
The 8 doesn't have it. You can only pull something out if they all have it.
These are for least common multiples, right?
Yeah. Yes, ma'am.
How come for the third row you multiplied it by x plus 4?
I just said pick any two and multiply. We have to multiply all that out. I just, on right here, on this line, I said pick any two and multiply them together. So I picked the second two. Picked x minus 1 and x minus 2. When we were at that step, I said pick any two of those and multiply them together. And then we end up multiplying all three of them together. But I need to pick two of them and multiply first, right? If I give you 3 numbers to multiply, if I say multiply these numbers together, I don't care what you do, but you need to start by multiplying 2 numbers together and then multiply it by the third. I don't care what you multiply. 2 times 3 is 6. There you go. You just multiply 2 together times the third one. Yes, sir.
So, to get to the gray highlighted, we're taking the greatest row?
We're just factored. All we did was we factored, and then we took the greatest, like right here, just as the instructions say, if it has common factors, use the highest power. Since there were 2 x minus 1s, we took whichever one had the highest power. They had the same power, so we just took one.
So you picked the one that has the highest power.
Right, like remember back here, we had x's, and we picked the one that had the highest power. Here, we have x minus 1s. We picked the one that had the highest power. They both had the same power, so I just picked it. All right, let's talk about this one. Let's talk about what is the least common multiple of just the numbers. What is the smallest number that they both go into? 12. So now I'm going to pick look at the x's here, and I'm going to pick which one has the highest power. Which one has the highest power? X to the 5th. I'm going to look at the y's, and I'm going to choose which one has the highest power. What am I going to choose? Done.
That's your answer?
Yep. Yes, ma'am.
Is it always multiplying 4 and 3 or?
Yeah, so we're always going to take the numbers that we've got there and just multiply them. Okay, let's move on to D here. We've got x squared minus 4 and x squared plus 5x plus 6.
Well, the first one's different from 2 squares.
Good. Difference of 2 squares. What is that going to break down into?
X minus 2 plus 6.
What about the second one? What does it break down into?
Negative, no, 6, negative 1. Right? 3 and 2, no. Yeah.
You're going to break it down.
3 and 2.
I need 2 numbers that multiply to give me positive 6 that add to give me positive 5. Do we all agree on a set of numbers or do we disagree? What are we on? What did we decide? 3 and 2. X plus 3, x plus 2. Do we agree that there's more than one x plus 2 up there, yeah? Okay, so that is an x plus 2 to the first power and x plus 2 to the first power. Everything else is unique, yeah? It's just those x plus 2. Those are the ones that are each to the first power. So there's an x minus 2. That's one of the factors. There's an x plus 3. That's another factor. Now I need to look at these two and pick whichever one has the higher power. They have the same one, so pick either. It doesn't matter. It's the same power. Okay. So from there, we are going to multiply. We've got x plus 2, x minus 2, and x plus 3. We are going to multiply this all out. Although, actually, I already know what 2 of those things together will be. Like, I can look at 2 of them and go, oh, I know what 2 of those are. Like, right, like if I pick this one and this one, you know where that came from? Right here. If I were to multiply that back together, it's just going to end up as x squared minus 4. Because look, when we factored it, it gave us x plus 2, x minus 2. So if I were to multiply those two back together, it would be x plus 2, x minus 2. When we multiply them together, we get x squared minus 4. That's that part. But I still need to multiply that times x plus 3. Let's do that. How do we do that? FOIL. First times first. What do I get when I multiply the first term times the first term? X cubed. The outer term times the outer term, what do I get? 3x squared. Inner term times inner term. Last times last. Anything we can combine? Nope. Where is this undefined? We're not doing that here. It's not a fraction. Just get in that mindset. You go like, no, I'm not looking for where it's undefined. There's no denominator. I don't need to worry about that. That's only when we have denominators. One more. We'll get as far as we can in here. Okay, so here's when we have unlike denominators. Adding and subtracting with unlike denominators, where the denominators are not the same. So this is kind of like the first page, except for all of a sudden, they're not the same. Here's our steps. We're going to factor each denominator completely. We're going to create a denominator, a common denominator by multiplying. We're going to figure out what each side needs to give them a common denominator, and then we'll figure out any places that it's undefined. Well, to do this, we need to know that, like, first of all, you should probably get the feeling that these denominators are not the same. They don't look the same, right? So to understand what this denominator is over here, because that one's a little more complicated, let's factor it and see what it actually is. X plus 2, x plus 1. So on the left, we have x minus 1 over x plus 2, x plus 1, plus x over x plus 1. You know what? They're not so far off from each other, are they? I mean, they're actually pretty similar. What is the one on the right missing? It's missing in x plus 2. And the way that you do fractions, let me go over here for a second here. Let's pause on this because I'm going to show you something and I want to make sure you understand what's going on here. Let's say that I wanted to add 1/6 and 1/3. And I was talking to a kid in elementary school. Let's talk him through what would go on here. Talk to me about what happens.
Well, you find that 6 is the common one.
Okay, so there's the least common multiple would be 6.
And then you can leave the top one because that's like you just multiply it by 1.
Okay.
And the bottom, you have to do what you multiply to the bottom to the top.
I love what you said. So here's, because I'm going to use this exactly what you said. To get from a 3 to a 6, this bottom would need to be multiplied by 2. Yeah? Like we all agree with that?
Yes.
But then you have to multiply the top by 2 as well. So we end up with 2/6. That's how we do this. And the 1/6 up top doesn't need anything. So we get 1/6 plus 2/6 ends up with 3/6. Now that shouldn't be anything new. But I'm going to do that exact same thing to a polynomial over here. What is this bottom missing over here? So the bottom needs to be multiplied by an x plus 2. But remember, I didn't just multiply the bottom by it. I also had to multiply the top by it as well. Remember when I did 1/6, I multiplied the top and bottom by 2? I have to do the same thing here. So what we're looking at here is we've got x minus 1 over x plus 2, x plus 1. Well, now this denominator here on the right is going to be x plus 1, x plus 1 times x plus 2. And the top will be x times x plus 2. Are we okay with what just happened there? I multiplied both the top and bottom by x plus 2 because it was missing an x plus 2 on the bottom. So we have to multiply the top and bottom by that to make it everything fair, just like we've always done with fractions. We're getting closer to where we can finish this up now. Here's an x minus 1 over x plus 2, x plus 1. But this numerator over here has some work that it needs, right? There's something that needs to be done to this numerator over here before we can start adding things. Yeah, let's distribute that x. X times x is? X times 2 is? Okay, now if you notice they have the exact same denominator. Their denominator is x plus 1, x plus 2. What is the numerator?
X squared. You forgot the x squared onto 2x?
Oh, I'm sorry, this should be a 2x. You're right. Sorry. My apologies. You're right. She said I forgot the x when I wrote it down.
So this should be x squared plus 2x?
Well, we're just adding and subtracting here.
Oh,
X squared plus 3x. There's an x plus a 2x would give me a 3x. Anything else? Now, we may be done. Are we okay?
so wait.
We're just adding x's and x squareds. That doesn't change exponents at all.
Okay, yeah. Okay, now I see it.
Okay. Now, we may be done here, or maybe that top factors, maybe it cancels out. I don't know. But actually, I am going to sit here and go, do I know two numbers that multiply to give me -1 that will add to give me +3? Then that's not going to factor. So here is my answer right there. Now, when I am looking for this, we do need to determine in this one, is there anywhere where this will be undefined? So I'm going to go back to the original here real quick. You always have to go back to the original, which was right back here. There's this, this, and this. So x plus 2 is not allowed to equal 0. So we'll go x is equal to -2. That's not allowed. So x cannot equal -2. We know that x plus 1 is not allowed to equal 0. So we get x cannot equal -1. And why am I not going to do it a third time even though there's 3 things in the denominator? Because it's an x plus 1. We already did x plus 1. So all of that works out to be x squared plus 3x minus 1 over x plus 1 times x plus 2. But x is not allowed to equal -2 and x is not allowed to equal -1. Let's pause there and we will pick it up tomorrow.